In this session, we are going to discuss about a special topic in Python, which is about how to copy things properly in Python. Copying is something which we see, which is quite easy when you are working with any programming language. You just assign two variables and things get copied. But in Python kind of programming languages where the things are working with references by default, things change a bit over here. And we are going to talk about two things in terms of copying today, and we are going to see how to fix what kind of issues can arise because of the default copying behavior in Python and how to fix it using a deep copy. And shallow versus deep copy is something which is available in other programming languages also, like in C, C++ kind of languages. We are going to explore something similar with regards to Python also. So let's start. First thing we need to understand regarding Python is again the concept of data types. We had discussed it in a previous session regarding data types, which is we can classify types into two categories based on what kind of types they are. For example, we have primitive types or the basic types, which are int, float, boolean, etc. And we have composite or non-primitive types, which are like lists, tuples, dictionaries, or maybe your custom classes or the even the built-in class objects that are available in Python. Now, to understand this shallow versus deep copy thing, which is also the title of our notebook, deep copy, let's start with an example. So these examples are not specifically with regards to shallow versus deep copy. It's just to get a basic understanding of how things work in Python or how variable assignment works in Python. Then we'll talk in more detail about deep copy. So let's consider this example. Let's say I have a list A equal to list of 1, 2, 3, and 4. Then I write something like b equals to a, and then I say print a and print b. So both the a and b print the same list because they contain the same list right now. All right. Now let's take this code, copy it over here, and let's try to do some modifications over here. Now I want to change the first element of this list, and I want to multiply it by, let's say, 10. So now the outcome for this code should ideally be 10, 2, 3, 4, and then 1, 2, 3, 4 for the list B. But if I run this code right now, it gives me 10 for both the lists. The reason is when you do this kind of variable assignment in Python, it's not actually copying anything. It's just saying that B and A are referring to the same list. So it's copying the reference, or you can say, or you can assume that it's copying the address pointed to by B and by A into B, but it's not creating a copy of the list actually. And this can create or cause issues when we are working with Python. Initially, when I started working with Python, I was also not aware of this thing because of which my code had certain issues, but later I realized how Python behaves and I was able to fix it. Another thing I'll add to this thing is if I just print ID of A and ID of B, so ID is the method to print, ID is a function to print the addresses of certain things. So if I print the IDs, you can notice that the IDs are same and hence the output is like this. Now to fix this thing, I can do something like a.copy. So copy is a built-in function, or I should say a method available inside the list class itself. So if I do something like this, now this code gets fixed, and you can also notice that the addresses are different. All right. So this seems to fix the code, and but we are still not there till the shallow and deep copy part. All right. Now let's take this example to the next level, and let's add another option to this thing. Let's say I'm going to have a nested list, a list inside a list. And before we talk about this, I'll show you one more way of doing the copy. Let's take this code again, let's paste it down. And if you would know, there is another way of copying this, which is b equals to a column. This is the way how slicing works. So whenever you slice a list, it actually returns a copy of the actual list. So now if I run this code, this also works exactly like how our previous code was working. But for our next example, we'll stick with the copy function, and let's get back. So now what I've done is I've copied, or not copied, I have created a nested list over here with two elements 10 and 20. What I'm going to do now is I'm going to go and say I want to modify the last element of the nested list and set it to, let's say, 200. Now, if I run this code, if everything works fine, if the copying works properly, then we should see 10, 2, 3, 4, 10, and 200 in the first list, and 1, 2, 3, 4, 10, 20 in the second list, which is B. let's run this thing and let's see the output. So the first element seems to be different, which is correct, but the last element of the list or the nested list is same. So it means the copy function is not actually creating a copy of the internal list. To verify that, let's again go and print the addresses, but this time of just the internal lists over here. So let's say bracket -1. And if I run this now, you can see that even though the outer lists are different, the inner lists are actually the same. So what Python does is, or what the copy function inside the, or the copy method inside your list does is, it creates a shallow copy of this list. So we are getting a shallow copy over here. So what it does is it just creates a new list, and inside that list it copies these data. Since integers and booleans and float kind of things are primitive types, so nothing matters over there. But for composite types, when Python would copy, it would just copy the reference, just like how we were saying A equal to B, B equal to A. Same way, inside this list, it would just copy the reference into the second list B and not the entire list. So this is the issue that's over here. So the solution to this thing already exists in Python, and that the solution is actually termed as deep copy. Deep copy means you are going to copy the nested objects separately, and there is a module available in Python called as copy. And let's get back our same code. And instead of writing this a.copy, instead of calling the method available inside the list class, we are going to call copy.deep copy and put this a inside the function call to deep copy and let's give it a shot. And now if you notice that our outputs are correct, also the addresses are different. Why? Because deep copy, while making a copy of this list, would check if the object requires a deep copy, then it would recursively try to copy the internal list to and create a new copy of it for the target or the new object. If I even go and put another list inside this thing, let's say I put an empty list over here, and then I go and say a bracket -1 bracket -1 dot append, let's say my name, and if I run this thing, okay, I missed the one, and if I run this thing, okay, I missed something again. It says int attribute has nothing called as append. What's happening over here? I'm saying get the last element, which is this list. From the list, get the last element, which is the empty list, and then I'm appending this thing to, okay, my bad. So in the previous step, I had changed it to 100. So it should be -2 equal to 200. Now this thing should work properly. Yeah. So now you can see even on 3 levels of listing, this is the outer list, then the inner list, and then the third empty list, which is inside. Even then our deep copy thing works perfectly fine. So this is from a list perspective. Same thing applies to other types, tuples, dictionaries, and even classes. So let me show you another example, but with deep copy for classes. I'll make a simple example. Let's say I have a class A. This class A would have a constructor which could go and add an attribute small a, or let's call it x, inside this class instance. Let's say self.x equals to x. And one thing I'm going to show you over here is, let's say I create a 1 equals to a with a value of 1. All right, and then I say print a1. Once I do this, it prints something like this. I don't want it to be printed like this. I want it to print better. So I'm going to do is str__ self. I'm going to override the default self implementation, which prints this, and I'm going to print something like this. I want it to look something like this, which is a, which is a class name, and the value of x equal to the actual value. So I wanted to print something like this. So I'll say return format string a bracket x equal to self.x. So if I run this now, it prints like this. That's what I expected. Now coming to the actual problem, I'm going to create another class B, and I'm going to say def underscore underscore init underscore constructor again. Self, let's say y, comma, this thing is going to take an object of the class A. So I'm going to say self dot y equals to y, self dot a equals to a, and then again the same str method because I want to print it properly, and self, and I'm going to return a formatted string again. Let's say b with the same format, y equals to self dot y, comma a equal to self dot a. Let's try to see what gets printed when we get an object of p. So p1 equals to p, and let's say the value is 2, and I am going to pass the even object over here, and then let's see what gets printed. Print p1. So I think this output seems to be correct. Now we can come to our shallow and deep copy business. So we have this class structure. We are going to take these two objects, and after these two objects, I'm going to create another object p2, which would be a copy of p. And we have already imported the deep copy, the copy module which contains deep copy. So we are going to just say copy dot deep copy bracket, let's say a1, and then we'll print p2. But before printing this time, we are going to modify the a1 object present inside b1. We are going to say b1 dot a1, not a1. It's being called as a inside b, so I'll call it a. And a contains an attribute x, so I'm going to say x star equal to 10. I'm going to multiply it by 10, and let's print both a1 and b, not a1, let's say b1 and b2. Let's put it like this. And once I run this, if you notice that the output of this thing is somewhat messed up. Let's see what went wrong. I by mistake made a copy of a1. That should be b1. Now I think this should be good. Now when we look at b1 and b2, so both have the same value for y, which is 2 and 2, and but the value of a which is changed inside b1 didn't get reflected into b2. So the deep copy module helps you to copy even custom class objects as well. And just one thing to remember is that uh, for very basic things, for example, if you already know that you have a list which is not nested or which doesn't contain anything else, which is just a simple list of something, then you can even use the copy method or the slice method. But if you know that your object is it can be nested or it's a complex kind of object which may contain some other things, you can use the deep copy method inside the copy module. So this is a solution for the issue, and the problem is shallow copy versus deep copy. So I think you understood this thing. That's it. Thank you.